Assalamu alaikum everyone. I hope you guys are doing great. In this video, we are going to start off with the new chapter that is vectors. So in some books it's chapter 9 and in some books it's chapter 8. It totally depends upon the book, but it is there in the syllabus for A2 maths. And according to the book which I'm following, it is chapter number 9. Vectors. Okay. Now, in physics, we are basically dividing all the quantities into two parts. Some of the quantities are considered to be vectors, some of the quantities are said to be scalars. What is the difference? A scalar is basically a quantity that has magnitude only. For example, distance. I traveled or I walked for 9 kilometers. For example, speed. I was going at a speed of 9 kilometers per hour, for instance. Okay. What is the difference in a scalar or vector? The difference is that when we talk about scalars, we only talk about the magnitude. Like we discussed distance, that was 9 kilometers. We discussed speed, that was 9 kilometers per hour. We did not specify the direction. However, when we talk about vectors, we talk about direction as well. For example, distance as a vector is going to be displacement. Displacement has both magnitude and direction. I traveled 9 kilometers in the east direction or in the west direction. I was going at a speed of 9 kilometers per hour in the east direction or in the west direction, right? Or towards the north. So here, when I'm adding direction, that is basically making my quantity a vector quantity. So now we know that for vectors, we have both the magnitude and direction. Both the things are important. We have both the magnitude and direction in case of a vector. Okay, so let's talk about the very first unit, that is 9.1, and it is the vector notation. All right, okay. Let's talk about the vector notation. Okay. Now, when we talk about the vector notation, this basically means that how do we represent a vector? Okay. So we have multiple ways. Okay. Let's talk about the two representations. I can write down a vector as xy as a column vector, or I can write it down as xi plus yj. So this is basically the column vector form, and this is basically the xi yj form, right? Here we are basically writing down the components separately. Okay, and how do we represent it on graph? So I'm going x units in the I direction. It's I, and y units in j direction. So this is basically the idea behind representing vectors. Now, this was just about writing down a two-dimensional vector. If I talk about three-dimensional vectors, I can write the same thing as x, y, and z, or I can write it as xi plus yj plus zk. Okay, and then I would just add the third axis. This is going to be z, and it's going to be in the k direction. So this is how we represent three-dimensional vectors or two-dimensional vectors, and this is all about the notation. Let's talk about one example just so we understand the concept. Now imagine that you have a vector and that vector is 3, 1, and -2. I can also write it as 3i plus j minus 2k, and this would mean that it is going 3 units in the x direction, 1 unit in the direction of the y-axis, and -2 units in the direction of z-axis, or 2 units in the direction of negative z-axis. Okay, so this is how we can write it down. So 3 units in positive x-axis direction. I'm not writing down the entire thing. 1 unit positive y-axis, and 2 units in negative z-axis direction. So this is just to explain the idea behind the understanding of vectors. Okay, all right, let's talk about some questions now, just so we understand the concept easily. Okay, question number 1. Write down the displacement from 2, 6 to 5, 7 as a column vector. Okay, right. So we have 2 points, it's A and it's B, and you need to write down the displacement as a column vector. So it's simple. First of all, we need to write it down as a vector. So it's AB. This is how we represent vectors. And for column vector, we need to find out the difference in both the x coordinates. So it's 5 and 2. It would be 5 minus 2, and it would be 7 minus 6. And this is going to give you 3, 1. Let me just write down these brackets properly, because some of you would think that I'm, writing down matrices. However, that's not the case. These are round brackets, okay? And this is basically the column vector. So how did I find the displacement? By finding the difference in the x coordinates and by finding the difference in the y coordinates. Okay, this was the first part of the question. Part B says, write down the displacement from P, that is 213, to Q, that is 7, 2, and minus 1 in terms of vectors I, J, and K. Now this is the second part. Okay, again, it is about the vector notation. You need to give the final answer in this form, like the form should have I, J, K. And again, the question is about finding the displacement. So it's very simple. PQ, even if it's the column vector or if it's other way around, we need to write down this notation is going to be I, J, and K. And for this, we need to find out the difference in the x components. It's 7 minus 2 plus the y components, 2 minus 1 plus the z components, minus 1 minus 3. And this is going to give you 5i plus j minus 4k, and this is going to be the answer. Now, certainly in both the parts, the notation was different. For the first part, we used the column vector notation, and for the second part, we used the notation where we had to write down ijk as the form. But the important part is that whenever we are representing a vector, we write down this arrow. That is important. And the second important part is that for displacement, we need to find out the difference of the respective coordinates. Okay, and then you would be able to do it very, very easily. Okay. All right. Let's talk about another question. It's question number 2. Okay. So, all right. Let me make a diagram for this. Okay. All right. So, all right. This is O, D, A, E, B, F, G, and this point is C. This is Q, and this is B. Okay. In the diagram, O, A, B, C, D, F, G, that's a cuboid with OA has 10 centimeters. This is 10 centimeters. AB as 6 centimeters. Okay, the entire AB is 6 centimeters. OD is 5 centimeters. So this part is 5 centimeters. The unit vector is I. This is I. This is J. And this is K. Are in the directions OA, OC, OD respectively. The point P is the midpoint of AB. Okay. This is basically the midpoint of AB. It's P. And Q lies on GF such that GQ is equal to 4 times QF. All right, okay. So the relationship over here is that GQ is equal to 4 times QF. All right, so for this, you can think about it this way, that this is 1 unit and you have 4 units for this, okay? But since the total length is different, so let's not write it down this way. I'll use that separately. Okay, all right. And then express each of the vectors OP, OQ in terms of IJK, okay? And you have been asked to express OP and OQ in terms of I, J, K. Okay. So I'll tell you how to do such questions. It's OP. So for OP, this is O. I'll go 10 units in the I direction and then halfway for AB. So that would be 3 centimeters, and this is going to be J. So for OP, I can write it as 10 units in the I direction and then 3 units in the J direction, because P was the midpoint of AB and the entire AB was 6. So for AP, it would be 3 only. And then it is OQ. Okay. From O to Q. So again, I can go from O to A, 10I, A to B, that would be 6J. Then if this is 5, this would also be 5. And then again, some part of I. We need to understand that part of I basically. All right, now using this, I can just make a rough ratio. I know that 4 units for JQ and 1 unit of QF. So it's 4:1. And then 5 is for the entire thing, and for the entire thing it's 10. So if I am interested in finding out this one, I'll cross multiply and this would give me x equals 2. So this is basically equal to 2 centimeters. This part is 2 centimeters and then this would be 8 centimeters. Okay, that 4 and 1 was just the ratio. Okay, so first of all, from A to O to A would be 10I plus 6J plus 5K minus 2I. Why? Look at it again, okay? From O to A, it would be 10I. This is the positive I direction, then positive J direction, then positive K direction. And then where I'm going like this, that's the negative I direction. So I wrote minus 2I. And finally, I can write it as 8I plus 6J plus 5K as the answer. All right, okay. Now this part was a bit complicated, but this is considered to be one of the examiner's most favorite question for some reason. And you would certainly be asked about, finding out the vector equation, not the vector equation, finding out the vector OP and OQ, and you'll have to think about it logically, right? So yes, this part was important. 1 unit of JQ is basically equal to 4 units of QF. So it meant that if I talk about ratios, it would be 4:1, and this 5 was basically the sum of 4 and 1, because I had 10. 10 was basically the length of the entire OA. So that is why I had to write it down this way. Okay, all right. Let's talk about some more questions. Question number 3, the position vector of point A is 3i minus j plus 2k. AB is equal to 2i plus 5j minus 3k. Find the position vector of B. Okay. Now, what exactly is the position vector? Let's talk about that first. For position vector, you need to understand it's basically, if the question is about the position vector of B, you are basically interested in finding out OB. It's basically the distance of that point from O in terms of vectors. Okay. So when the question says position vector of B, that basically means that you have been asked to find out OB. So this is the question. Okay. How do we find out OB? Now you've been told that the position vector of point A is given. So this means that OA is equal to 3i minus j plus 2k. This is OA. And you need to find out OB. So let me tell you, AB is basically equal to OB minus OA. This is a rule. This is a rule that if you have a vector AB, you can write it as OB minus OA. So since we're interested in finding out OB, I can write down OB as AB plus OA, and AB is going to be 2i plus 5j minus 3k, and OA was 3i minus j plus 2k. So 2i and 3i would be added, and this would give you 5i plus 4j minus k. So this is going to be the answer. So again, the question was about finding out the position vector of P. We had to find out OB. And for OB, always remember the rule is same. We are always going to use this very thing. Let's say we had BD. So I can write down BD as OD minus OB. Okay. So the rule is same. So even if you have some other vector, you can write it down this way. All right, let's talk about one last question. Question number 4. It says if A has coordinates 3, -2, 4, and B has coordinates B 5, -3, and 2, find as a column vectors AB and BA. Okay, perfect. So same idea would be used here as well. AB is basically OB minus OA. This is OA and this is OB. So I can write it as 5 -3. Let's write it down as a column because this clearly mentioned that. So 5 -3, 2, and -3 -2, and then -4. And this is going to give you 2, 1, and then -2. This is what we are going to get for AB. And when the question is BA, so BA is basically OA minus OB. And if I write it down, OA is 3 -2, 4, minus 5 -3 and 2, and this is going to give you -2, 1, and 2. So this is going to be the answer for this scenario. So in this class, we learned how to write down vectors using different notations. We know what exactly is a column vector. This is a column vector and this is writing down vector in terms of I, J, K. And then we discussed a few questions. So displacement was basically calculated by subtracting the coordinates, and it was clearly mentioned that you had to give the answer as a column vector. That is why this was the answer. In part B, it said we were supposed to give the answer this way. So this was the answer. Then question 2 was extremely important. You will come across a lot of questions of this type. Here you were asked to find out OP and OQ in terms of IJK. So we just had to use logic and just, start moving from O to P. So that would be 10 centimeters in I direction. That's why we had 10I. Then 3, centimeters in J direction. This total was 6 centimeters, and when we will half this, it would be 3 centimeters till P. And then the next question was about discussing the position vector. So we know, think about position vector as the location of a point on the graph. For example, in this question, the coordinates of A were this, and same was the position vector. The coordinates of B were this, and same was the position vector. Okay. So if you were asked to find AB or BA, it would be OB minus OA. And for BA, it would be OA minus OB. So I just subtracted and I was asked to give the final answer as a column vector. This is how it was. So I hope you guys were able to understand everything and you like this video. If you are more interested in proper live sessions where we are discussing all the contents and everything, use the link in description to get yourselves enrolled for our live classes. Thank you so much. Take care and Allah Hafiz.